Let's solve equations involving inverse trig functions. Now we're going to do 4 examples here, 2 that are similar and then 2 different ones. So bear with me here. So first we're going to solve y equals 3 cosine of 2x for x. We're going to get x by itself when x is on the interval 0 to 2 pi. This part is not super important at this point. So let's just think about if we want to isolate x. Well, first we have to isolate the trig function. And we do that by dividing both sides by 3. So I get y over 3 equals the cosine of 2x. All right, now think about this. We need to get rid of the trig function, right? Because if we want to isolate x, we have to get rid of the cosine. Well, just like with anything else in math when you're solving equations, if you want to get rid of something, you do the inverse. So what is the inverse of cosine? Well, inverse cosine. So if I inverse cosine both sides, the inverse and the cosine cancel each other out. And I'm left with the inverse cosine of y over 3 equals 2x. So to get x by itself, we simply divide both sides by 2. And I end up with an answer of x equals 1/2 inverse cosine of y over 3. Because remember, dividing by 2 is the same as multiplying by 1/2. So there's the first one. The second one is similar. Y equals 4 times the tangent of 3x. Okay, no problem. We start by dividing by 4. So y over 4 equals the tangent of 3x. Again, I want to get x by itself. So I take the inverse of tangent. So inverse tangent of y over 4 is going to equal 3x because inverse tangent and tangent will cancel out. And then to get x by itself, I divide by 3. So 1/3 times the inverse tangent of y over 4. So you notice with the first two, we get kind of this abstract answer because we have this variable y, and that doesn't really help. So the next two, we're going to use this process, but we're going to actually solve and get an answer. So we're going to solve 2 arcsine x equals pi. Now, I start with this because I think it's important to recognize that the arcsine is the same as the inverse sign. Now, I prefer to write it as the inverse sign, but that's just me. And so we're like, okay, I have 2 inverse sine of x equals pi, and I need to solve this for x. Great. Same basic idea of, well, I divide both sides by 2. So I have the inverse sine of x equals pi over 2. Well, if I want to get rid of the sign, right now I have the inverse sign. So what is the inverse of inverse sine? Well, we're going to take the sine of both sides because the sine and the inverse sine will go away, and I have x equals the sine of pi over 2. Now, friends, you know the value of sine of pi over 2. At pi over 2, what is the value of sine? And that answer is 1. So in this case, x is 1. Let's do another one of those. Solve 3 arctan x equals pi. I'm just going to rewrite that the way I like it, and that is with the inverse sign. So 3 inverse tangent x equals pi. Wonderful. Love this for us. We need to isolate the trig function. So I divide by 3. The inverse of tangent x equals pi over 3. Okay, if I want to get rid of the inverse tangent, well, the opposite of the inverse is just the function itself. So the inverse and the tangent go away, and x equals the tangent at pi over 3. Well, we know that the tangent at pi over 3. So what is tangent? We got to think a little bit more because tangent is not the prettiest. So remember that tangent is y over x. So at pi over 3, our y value is radical 3 over 2. And our x value is 1/2. So we can say, well, radical 3 over 2 divided by 1/2 is the same as radical 3 over 2 times 2 over 1, which gives us radical 3. So x equals radical 3. And that's doing some solving equations involving inverse trig functions.